So one of the homework problems talks about high and low tide. And just so that I'm not assuming something that I shouldn't, let's talk a little bit about high and low tide. So due to the influence of the sun and the moon, you're going to get the water levels on the ocean are going to shift. They're going to go up and down. And so, you know, kind of zooming in a little bit on this photo, it's the same dock taken at two different times, taken at high tide and low tide, and you can see the water's run out, like somebody drained the bathtub, that kind of thing. And this thing is going to happen in cycles throughout the day because of the sun and the moon. And what it's going to look like if you're just looking at a yardstick on or in the shoreline is that the water level is going to go down and then up and then down and up in kind of repeating pattern. And at the bottom, that's going to be low tide, and the top is going to be high tide. And it's going to continue to go up and down and up and down. But if you move this out over time, if you don't just do up and down, if you start adding some kind of a linear component to it at a time, it's going to trace out kind of like that. It's going to be a sine or a cosine wave depending on where you start the pattern. So in that sense, we can work with things, and they ask us to fit a curve to this data. So let's take a look at some things here and see what we can figure out. So one thing that they tell us is that the length of the time between consecutive tides is 12 hours and 28 minutes. So what they're giving you here, wait for it, can you tell me? What's that 12 hours and 28 minutes represent? That's going to be the period. Now, we're going to convert everything to just units of hours. This problem is going to work with military time. So that means 0 hours military time was 12 a.m. And then, for instance, 1600 hours would be 4 p.m., that kind of thing. But everything's going to eventually be done in terms of hours. Now, a couple other things to mark off during as we do this. High tide occurred at 12:28 a.m. Now, they take that 12, that's really a 0 in military time. The 28, if you divide 28 by 60 to convert it to hours, you get 0.47 hours. And that's where high tide occurred. High tide was at 5.92 feet. So let's put that on a little graph here. So that's going to be 5.92. Low tide is going to be at 0.8 of a foot. So 0.08. Let's see. So you had high tide at 12:28 a.m., which we'll call 0.47. And low tide is going to occur at 7.137 hours. So 7.137 hours is where you're going to be here and here. And let's see if we can't fit a curve here in between. So let's see. I think I've got all the relevant data that I need. So the curve that we're going to fit, do they ask us for a sine or a cosine? Let's just use a sine. Let's see. Yeah, I think they want us to use a sine, something of this form. Now I'm going to write mine a little different than the book does. Y equals A sine bx plus c plus d. So A is going to be the amplitude, and our curve has to look something kind of like this. Now, figures. Let's see if I got another one. So we need to figure out a couple things here. Now, this middle line here, the distance either above or below that middle line is going to be your amplitude, which is A. So what we can do is figure out where that middle line is. And to figure that out, we can average these two. So let's do that. If I take 5.92 plus 0.08 over 2, that gives you 6 over 2 or 3, and that's going to be D. That's going to be your middle line where you're going to shift up the graph to. So that's going to be D. So 1 down, 3 to go. Let's see. So now our function is y equals a sine of bx plus c plus 3. Let's figure out what a is next. A is just going to be the distance between this line, y equals 3, and the top here or the bottom here. You can either subtract this minus 3 or 3 minus this. Either way, that distance, A, is going to be, we'll do 5.92 minus 3, gives me 2.92 for my A. So again, let's update our model. Y equals 5.92 times sine of bx plus c plus 3. Now we're starting to get to the harder ones. So the first are worth a couple of points. Next we're worth a couple more than a couple points. Let's see if we can't figure out what b is. Now you might remember that the period of a function is 2 pi divided by b. You could turn this relationship around. If you multiply both sides by v and divide by the period, you get b equals 2 pi divided by the period. And the good news here is that we know what the period is. So what's that period? Well, that period was 12 hours and 28 minutes. So let's turn that into let's turn that into a decimal. 28 divided by 60 is 0.466666 or 467. So 2 pi divided by 12.4666. So I'll do it this way. Let me add 12 to that. And here's a little pro tip for you, a little cool thing you can do. Let's store that. Hit the store key down here. Store that in X. And I'll take 2 pi divided by X. And that gives me, call it 0.504, rounding it off to 3 digits. That's going to be my B, 0.504.
Could you show us how you stored it again?
Yeah, so let me fire up my calculator here so it's a little bit easier to see. And I like this, it just takes a second to warm up. So let's exit out of this. Let's put something there and then quit. Clear all this stuff out. So you can follow along with my keystrokes at the bottom here. Let's first of all calculate that number, 28 divided by 60. And then I'm going to add 12 to that because that's going to give me my 12 hours and change. If you hit the store key above the on button on the lower left side, store that in X. Then I can take things like 2 pi, so 2 pi divided by X, and get approximately 0.504. So, yay. So, we're almost done. And what I want to do is I want to add a little detail here that I didn't add the other day that, might be helpful in terms of solving for C. So let me do that now. So updating our function again, we've got y equals 5.92. Let's see, no, 2.92 I should say. 2.92. Yeah, this A should be 2.92. Glad I caught that. 2.92 times sine of 0.504 x plus c plus 3. So now the next thing to do is to figure out, well, what is x? So what we can do is take advantage of the fact that we know the coordinates of this point. This point has coordinates of 0.470 and 0.592. Our graph literally passes through that point. And that's helpful because if you look at this here, right now I've got 3 unknowns. I don't know what y is, I don't know what x is, I don't know what c is. Ultimately, I want to solve for c. So if I put in the coordinates of that point, here's my x and here's my y, I get 5.92 equals 2.92 times the sine of 0.504 times 0.470 plus c plus 3. So I've got a lot of work to do, but it's not hard work. For instance, the first thing I'll do is I'll subtract 3 from both sides. And I get 2.92 equals 2.92 times sine of something plus c. Let's figure out what that something is by multiplying those two together. So 0.504, let's just clear this out. 0.504 times 0.470. I'll just do 0.47. 0.23688. So 0.26388 plus c. So I'll put that in for c. And I want to solve for c now. Well, let's make my life even easier.
Is it
0.26, did I copy it down wrong? Let's see.
You did point.
Oh, I did, a little dyslexia here. Yeah, the 6 and the 3 are interchanged. Thank you. 23688. Let's divide both sides by 2.92. 2.92. And I think I can get this one right without a calculator. That's going to be a 1 equals the sine of 0.23688 plus c. Now, we're going to employ a little bit of a trick here that we have to do because we haven't discussed inverse trig functions yet. And what I want you to do is I want you to think about the trig function itself. For instance, sine of theta equals 1. Now we talked about this in our other video here. Where on the unit circle does the sine function equal 1? What angle in radians? So think about it in radians, okay, and sine is which coordinate on the unit circle?
Oh, the y.
The y coordinate. So where's the y coordinate equal to 1 on the unit circle? What angle in radians?
Kind of got lost.
Well, I'm looking for the angle where the y coordinate is 1. And I've got some of the y coordinates written up here. So can you find the y coordinate of 1?
Right, that would be the 90-degree
90-degree angle, and in radians, 90 degrees is
pi over 2.
pi over 2. So if the sine of something is 1, that means the angle has to be pi over 2. Now, I mentioned this in class the other day, but I didn't really get to give quite as much of a preamble to it. This angle has to equal pi over 2. That's the only way that you can take the sine of something and get a 1, is if this angle is pi over 2. So what that's saying is 0.23688 plus c equals pi over 2. If I move this to the side, c equals pi over 2 minus 0.23688. And that should give us our value of c. So let's do that. C is going to equal, that's going to be about 1.57. And I'll do it on my calculator over here. So I'll do pi over 2. Oops. Let's try that again. Let's clear this out here. I'll do pi over 2. And the cool part is I can do minus my previous answer, which I can get by hitting the second key and then the opposite key. Minus my previous answer gives me about 1.334. So I can put that in as my last update to my function. Let's see, over here. So overall, my function is y equals 2.92 times sine of 0.504x plus 1.334 plus 3. Now, after you do all this work, you might be saying, well, wow, I did a lot of work. I don't know if I got it right. Well, you can check your answer this way. Let's plug that into our graphing calculator. So let's see here. Let me clear out all this stuff, clear that, and I'll enter this function into my graphing calculator. I want 2.92 times sine of 0.504x plus 1.334 parentheses plus 3. So there's my function. Now the window I want to choose, well, you don't have to reinvent the wheel. I know that the minimum is going to be about 0.8, so let's go down to the x-axis. It's always nice to see that. And let's go up to 6, just to give ourselves some nice, easy things. Now, this repeats itself every 12 or so hours, so maybe I'll go out to 13 or so. That way I can see one nice full period of this graph. I'm not trying to get it exact. So window 0 to 13 on the x-axis, scale of maybe 1. Then on the y-axis, 0 to 6. And there's my graph. But a good question would be, well, how do I know that it passed through the right point at the right time? Well, we should be able to trace our graph at the right time. And that right time was at 0.47 of an hour. So let's see what happens. If I type in, if I hit the trace key, and as soon as you start typing in a number, it'll open up a little window at the bottom to show you what number you're typing in, 0.47. I guess we'll type in the 0, we don't need to. And take a look. At 0.47, what y coordinate does it give you? It gives you exactly 5.92. So we nailed it. This is perfect. Good? Got it?
Yes.
Nice. Well done.